Section 3, Climate Regions. When you turn on the television to find out the day's high and low temperatures, you are checking the local weather. Weather refers to the changes in temperature, wind direction and speed, and air moisture that take place over a short period of time. When geographers look at the usual predictable patterns of weather in an area over many years, they are studying climate. The sun. Earth's climate is linked directly to the sun. As you recall from Chapter 1, the Earth does not heat evenly. The tropics receive more of the sun's heat energy and the poles receive less. The movement of air and water over the Earth helps to distribute the sun's heat more evenly around the globe. Winds. Air in the tropics, which is warmed by the sun, moves north and south toward the poles of the Earth. Colder air from the poles moves toward the equator. These movements of air are winds. Major wind systems follow patterns that are similar over time. These patterns, shown in Figure 4, are called prevailing winds. Because the planet rotates, winds curve across Earth's surface. The winds that blow from east to west between the tropics and the equator are called the trade winds. Long ago, sailing ships used these winds to carry out trade. The westerlies, which blow over North America, move from west to east in the area between the tropics and about 60 degrees north latitude. Storms. When moist, warm air rises suddenly and meets dry, cold air, major storms can develop. In the summer, these storms can include thunder and lightning, heavy rain, and sometimes tornadoes. Tornadoes are violent, funnel-shaped windstorms with wind speeds up to 450 miles, 724 kilometers per hour. In the winter, storms can become blizzards that bring much snow. Other types of destructive storms are hurricanes and typhoons. Hurricanes occur in the western Atlantic and eastern Pacific Oceans. Typhoons occur in the western Pacific Ocean. These storms arise in the warm ocean waters of the tropics and can reach great size and power. Some are as much as 300 miles, 483 kilometers, across and create strong winds and heavy rains. Ocean currents. The steadily flowing streams of water in the world's seas are called currents. Like winds, they follow patterns, which are shown in Figure 5 on the next page. Currents that carry warm water to higher latitudes can affect the climates in those latitudes. For example, the North Atlantic Current carries warm water from the tropics to Western Europe. Winds blowing over the warm water bring warmth and moisture to Western Europe, which enjoys an unexpectedly mild climate. El Niño and La Niña. Every few years, changes in normal wind and water patterns in the Pacific Ocean cause unusual weather in some places. In one of these events, weakened winds allow warmer waters to reach South America's coast. This change alters weather there and beyond. These conditions are called El Niño, Spanish for the boy. In an El Niño, very heavy rains fall on western South America, causing floods. Meanwhile, little rain falls on Australia, Southern Asia, and Africa. Also, North America may see severe storms. In some years, the opposite occurs. producing conditions called La Niña, Spanish for the girl. La Niña causes unusually cool waters and low rainfall in the eastern Pacific. In the western Pacific, rains are heavy and typhoons can occur. Landforms and climate. Sun, wind, and water affect climate, but the shape of the land has an effect on climate as well. The distance between landforms as well as their nearness to water influence climate. Landforms and local winds. Some landforms cause local winds or wind patterns that are typical only in a small area. Some local winds occur because land warms and cools more quickly than water does. As a result, cool sea breezes keep coastal areas cool during the day. After the sun sets, the opposite occurs. The air over the land cools more quickly than the air over the water. At night, then, a cool breeze blows from the land out to sea. Local winds also occur near tall mountains. When the air along a mountain slope is warmer than the air in the valley below, it rises and a cool valley breeze moves up the mountain. Mountains, temperature, and rainfall. The slopes of a mountain facing the sun can heat more quickly than nearby land. Higher up in the mountains, however, the air is thin and cannot hold the heat very well. As a result, mountain peaks are cold. This explains why some mountains in the tropics are covered with snow. Mountains have an effect on rainfall called a rain shadow that blocks rain from reaching interior regions. As warm, moist ocean air moves up the mountain slopes, it cools and releases its moisture. As a result, the side of mountains facing the wind, called the windward side, receives large amounts of rainfall. As the air passes over the mountain peaks to the other side, called the leeward side, it becomes cool and dry. As a result, the land on the leeward side of the mountains is often very dry. Deserts can develop on the leeward side of mountain ranges. Climate zones. As you have read, the effects of wind, water, latitude, and landforms combine to shape the climate of an area. Scientists have found that many parts of the world, even though they are very distant from one another, have similar climates. Southern California, for instance, has a warm, dry climate similar to that around the Mediterranean Sea in Europe. These areas have the same climate zone or similar patterns of temperature and precipitation. These regions would also have similar vegetation. Climate zones include biomes, or areas such as rainforest, desert, grassland, and tundra, in which particular kinds of plants and animals have adapted to particular climates. Major climates. Scientists have identified 5 major climate zones, which are described in the chart below. 4 of these zones have several subcategories. For example, the dry climate zone is subdivided into steppe and desert subcategories. These generally dry climates differ slightly in rainfall and temperature. Locations in the highland zone show great variation. In these areas, altitude, the position of a place toward or away from the sun, and other factors can make large differences in climate, even though 2 locations may be near each other. Urban climates. Large cities show significant climate differences from surrounding areas in their climate zone. These urban climates are marked by higher temperatures and other differences. Paved streets and stone buildings soak up and then release more of the sun's heat energy than areas covered by plants. This absorption leads to higher temperatures, as much as 10 degrees to 20 degrees Fahrenheit, 6 degrees to 11 degrees Celsius, higher than in the nearby countryside. These different heat patterns cause winds to blow into cities from several directions instead of the prevailing direction experienced in rural areas. Some scientists believe cities also have more precipitation than rural areas.